So a couple of videos ago, we looked at finding the arc length of a Cartesian curve. So going from this point A up to this point B, we estimated the length of the arc by the hypotenuse of this right angled triangle here. So we took a little bit of x, so delta x, and a corresponding little bit of y, delta y, so we've really zoomed in here. And so the length of the hypotenuse we referred to as delta s. And from that, because we've got a right angled triangle, we could then say that delta s all squared is equal to delta x all squared plus delta y all squared. And then what we did was we divided all the way through by delta x all squared. And that allowed us to find the arc length of a Cartesian curve. But what if our curve isn't given as a Cartesian equation, it's given parametrically? How can we work with it there? So what we'll do is we are going to divide through by delta t squared. So effectively dividing through by using our parameter t. So dividing through by delta t squared is going to give me delta s over delta t all squared. Now I could write it as delta s all squared divided by delta t all squared, but I think we know that we can just simplify it straight to that, to writing it like that. So then we'll have delta x over delta t all squared and delta y over delta t all squared. Okay, so then what I can do is I can square root both sides, and we can write delta s over delta t is equal to the square root of delta x over delta t all squared plus delta y over delta t all squared. Now we can turn these into derivatives by looking at delta t tending to 0. So as delta t tends to 0, what's going to happen is that delta s over delta t will get closer and closer and closer to ds over dt. Delta x over delta t will get closer and closer and closer to dx over dt. And delta y over delta t will tend to dy over dt. And so, as delta t tends to 0, this will get closer and closer and closer to ds by dt is equal to the square root of dx by dt all squared plus dy by dt all squared. Then we can integrate both sides and say that s is going to be equal to the integral of the square root of dx by dt all squared plus dy by dt all squared dt. And we can integrate that between two limits given parametrically, so t1 and t2, for example, which correspond to these places on the curve. So from A up to B, that's where we've got t1 and that's where we've got t2, and we can put those as the limits in my integral. Okay, so this is where that formula for parametric curves comes from, and we're going to see a couple of examples of using it in the next couple of videos.